I'm Anil Kumar. Welcome to my series on advanced calculus. Many of my subscribers are now from universities and those who are seeking admission to good universities. Some of them are preparing for IIT's joint entrance exam. And so I get questions which are very tricky and difficult to answer. So I thought let me take help of some good functions so that we could answer those questions. Now, power series is one of the very powerful tool which can help answer many questions based on calculus. So I am introducing this to my playlist. Here is the very first video where we'll start from the very basics and understand what is the importance of power series and how does it help to solve different types of questions. So this particular video is extremely important for all those who want to take advanced level of calculus in universities. Let us begin with a very simple series which is 1 plus x squared plus x cubed plus so on, right? So as you can see, this is a geometric series, right? So we have a series which is a geometric series. What you also see is that the first term a is 1 and every time it is being multiplied by x. Second, it is also infinite series. Now, if it is infinite series, you know the formula of sum of infinite series, right? So if it is a geometric series, infinite series sum formula is a over 1 minus r. Now, it is important to understand this term r should be less than 1, absolute value, so that it is converging, right? If it is not converging, then the sum will be infinitely large. Perfect. So these are very basic things which you need to understand when we work with power series. Now, as you can see here, we have so many elements. Now, if I write the sum of this a over 1 minus r, where r is x, you can straight away see that I could write the whole series as equal to a is 1 for us, right? So, if I apply this formula where a is 1 for us and r is x, right? So, in that case, I could write the whole series as 1 plus x squared plus x cubed plus so on as equal to the sum, where a is equal to 1 and r equals to x, so it becomes 1 over 1 minus x, where the absolute value of x should be less than 1. Perfect. So what have I done here? At this stage, the most important thing which you learn here is that I have converted a power series, infinite power series. So these are all polynomials, correct? So I have converted infinite power series into a function. You can see it the other way also, and that is to say, we have split the function as sum of infinite power series. Perfect. So, if there is a complicated question, we could break it down. And what we have done here is we have really broken down into infinitely small elements, and that should really help you to solve problems, right? So that provides better solutions. So that is the concept. Well, better solutions to really complicated questions. So that is important to understand. Perfect. So what we have done here is that the whole series have been written as a function. So now we have a function which is written as 1 over 1 minus x, and this is equal to. Now I could use the summation sign to write the whole thing, right? So let's understand the summation sign. You see the x power is increasing, right? So first term, the power is 0. Second term, the power is 1, right? So the power is actually starting from 0 and then increasing and it's going to infinity. So we could write this as sum of the function, which is x to the power of n, where n is going from 0 to infinity, right? So that is the short form of writing your series, perfect, where absolute value of x is less than 1 because we want it to converge, right? Otherwise, this sum is infinitely large, correct? So that is how we have represented our first function. So let's call this as our first function, 1 over 1 minus x. So we'll actually use this function in following videos where we'll find how to split logarithmic functions and write them as a power series, right? So this is one part we've done. Now another interesting thing which I want to take right here is what happens if I replace x with minus x squared, right? So this is one function. Let me call this as our equation number 1. And now if we replace x with minus x squared, then what happens, right? That is very interesting to see. So if I do that, then what happens is that the function, we get this 1 over 1 minus, I'm replacing x with minus x squared, minus x squared. Do you see that? So when I do that, this power series will become minus 1 to the power of n. So n equals to 0 to infinity. So here we have minus, you can write minus x squared to the power of n. You write like this. Is it okay? So that should give you infinitely small elements being added, n equals to 0 to infinity. And what we get here is minus 1 to the power of n, and we get x to the power of 2n, right? So 2n. So we get a new function now, right? So this is a new function which could be written as 1 over, when you open this up, 1 plus x squared, right? And if I want to write it as infinite elements, let us see how to expand it. If n is 0, then this will be going to be 1, right? So this is going to be 1 for n equals to 0, so we get 1. If n is 1, this is negative, and here we get x squared, right? So we get minus x squared. If n is 2, this becomes positive, right? So whenever n is an even power, this becomes positive, and that becomes 2 times 2 as x to the power of 4. Right? So when we have this, we have x to the power of 6 plus x to the power of 8 plus so on. So we get a new series, right? So we get another series. Let me call this as our series 2. So these are the first two series with which we are going to work with. And in this playlist, I'll try to arrange them in particular order so that if you start from the very first one, you get all the concepts. Later you learn about Taylor series, Maclaurin series, and then we'll solve questions relating to limits, derivatives, and integrals using complicated functions which will be or could be in university level exams or tests. Perfect. So we have worked out two series. One is 1 over 1 minus x, which could be written as sum of infinite elements, x to the power of n. The other one is 1 over 1 plus x squared. And here we have 1 minus x squared plus x to the power of 4 minus this. And that is our second series, right? Now in the next video, we will see how to get expansion for logarithmic function using our first series. And we'll use the second one to get tan inverse x. So these series will be utilized to give you, that will give you the log function, and this will give you tan inverse function. Let's see how, okay? So that is how we are going to work. And I hope it is interesting and useful and you feel connected as if like what is going on, right? So another important thing always to keep in mind is the value of x. So it is always converging, and what we have considered these two examples, the absolute value of x should be less than 1. Perfect. Otherwise, whatever formulas we are using are not valid, right? So I hope that helps. Feel free to write your comment, share your views. And if you have questions now regarding power series, or you know what type of questions we are getting into, right? You can post them and I'll be in a position to solve them for you. Feel free to make your suggestions. If you like and subscribe to my videos, that would be great. Share my videos with your friends. Thank you and all the best.